Assalamualaikum. I hope students, all of you are well. So today we are going to study the radicals and radicands. But before we proceed further, let me ask you some questions. If I write down x power 3 is equals to or plus 4, in this expression, x is called what? Yes, x is a variable. But at the same time, we call this variable as base over here. Because, why we will call it as base? Because we have a power raised to this base. 3 power raised to this base. So this is 3 over here is called power. Or what do we else call it? Exponent. Right? And 4 over here is called what? 4 is a constant. What about the number which is written beside or before the variable? For example, if I write down 9 over here, then 9 is called what? Coefficient. This is what you have studied in the previous classes about the variables, exponents and constant and the power. Now if I write down x power n is equals to a, and I want to eliminate the power n from here, what will I do? I will take power 1 by n on both sides. Power 1 by n on both sides. Here n would be cancelled with n, because we can write it like this, n into 1 by n. N would be cancelled with n. And here we'll have a power 1 by n. X is equals to a power 1 by n. So what do we call this? This is called nth root of a. This is called nth root of a. X is equals to a power 1 by n. There is another way to write down the numbers in which we have exponent as a fractional form or 1 over n form. So we will introduce a radical sign like this with a as a radicand, and this n would be written over here. Not 1 over n, we will write down n. So here we will call, this is called the nth root of a. Fine. Here a is a real number. Right? A is a real number. And n is what? N is a positive integer which is greater than 1. It is a positive integer which is greater than 1. So we can say n is greater than 1, or what else we can say? The integer which is greater than 1 is 2. So we can say n is greater than and equals to 2. Both are correct. Fine. So here is any real number. N is a positive integer which is greater than 1. And we can also say it is greater than 1 or equals to 2. So x is called the nth root of a. Here I would like to tell you that this is called what? A radical sign. This is called radical sign. The number written inside the radical sign is called what? Radicand. This is called radicand. And what about this n? This n is called index of the radical. This is called index of radical. So this is the way we have studied about the radical, radicands and index of radical. So let us see the difference between the radical and the exponential form. So let us see few of the examples. Here, if I write down cube root of x. So here the radical sign is obvious. A radical is this one. What about the radicand? What is radicand over here? Radicand is x. And what about the index of radical? Yes, students, index of radical is 3. Fine. Similarly, if we take another example, for example, 9x into y and whole, this is a radical sign, fifth root of n into xy. So, here a radical sign is this one. What about the radicand? Yes, our radicand over here is 9xy.
कंटिन्यू कर लें, ये वाली लाइन दोबारा रिपीट कर दें. ये नंबर 2 जो है ना, ये सारे ही कर लें. लिखा रहने दे, बस एक्सप्लेन वर्ब.
इस वाले को एक्सप्लेन कर लेते हैं.
कंटिन्यू.
So let us take another example. Here, fifth root of 9x power 3. So here our radical sign is obvious. Which is our radical sign? This one. What about the radicand? The number written inside the radical is called radicand. So radicand in this example is what? 9x cube. And what about the index of radical? Index of radical. Which one is the index of radical? The number written above the radical sign, that is 5. So these are the few examples of the radicals. So let us see the difference between the radical form and the exponential form. If I write down, let us take an example, 9x cube. I am going to take the same example, fifth root of 9x cube. This is the radical form. If we convert it into the exponential form, we will have 9x cube, and this radical sign would be replaced with the brackets and power 1 by 5. Whenever we write down the radical in the exponential form, our power would be written in this reciprocal form. Fine. So this is the difference between the radical form and the exponential form. Let us solve few of the examples from this exercise. Before we proceed for the exercise, we have to study the properties of the radicals. There are 5 properties of the radicals. First property says, if we have a product of two numbers under a same radical sign, we can write down it as nth root of A multiplied by nth root of B. That is, radical sign could be written on both of the numbers separately, and the product of these two numbers will take. For example, if we have 9 into x cube root of 9 into x. So this property says we can write it like this, cube root of 9 into cube root of x. Right? So this is the first property of the radicals. I hope it is clear to you. Now the second property of the radical says, if we have nth root of the division of two numbers or a fraction form, so we can write down it as nth root of A divided by nth root of B. Right? For example, if we have 2 over 3x and we take fifth root of 2 over 3x. So how can we apply this property over here? That is fifth root of 2 divided by fifth root of 3 into x. I hope this property is clear to you. Now the third property says, if we have mth root of A, right? We have two radical signs. So we can write it like this under a one radical sign, n into m, that is n into nth root of A. So let us take an example for this property so that this property is clear to you. If we have square root of cube root of a number x, so how would we write? let us take some number 9x. So how would we write? We can write it under this one radical sign 9x, and 2 into 3 would be multiplied with each other, that is 2 into 3 is 6. Fine. I hope this property is clear to you. Now the fourth property says if we have nth root of a power m, nth root of a power m. So this power could be written on the nth root of a. We can write it like this: nth root of a whole power m. Nth root of a whole power m. For example, we can take an example over here. If we have 2 power 3 and we are going to take square root of, or you can take fifth root of 2 power 3. Can we write it like this? 2 fifth root of 2 and whole power 3. Fifth root of 2 and whole power 3. So this is the fourth property. Now fifth property is a very simple property. If we have nth root of a power n, what can we write it? We can write it like this: a, that is power n and the root n will cancel each other. How they will cancel each other? As all of you know, we can write it like this: a power n. And what about this radical sign? Can we write it like this: power 1 by n? Yes. And then in the next step, how would we write it down? A power n into 1 over n. So n would be cancelled with n, and we will have a equals to a. So students, let us start exercise 2.3. Exercise 2.3 is a very simple exercise. Question number 1 of exercise 2.13 is write each radical expression in exponential notation and each exponential expression in the radical notation. Don't simplify. So it's clearly written that there is no need to simplify it. We just have to convert the radical form into exponential and exponential form into the radical. First part of this question is cube root of minus 64. Cube root of minus 64. Now this is which form? This is a radical form. Now we have to convert it into the exponential form. So very simple, minus 64 and whole power would be what? This 3 when converted into the exponential form would be written as 1 by 3. So this is the radical form, and this is which form? Exponential form. Okay students, now let us see its third part. Third part of the same question is minus 7 power 1 by 3. Minus 7 power 1 by 3. Now as all of you remember that a was a positive number when we defined the radical. When we have defined the radical form, a was a positive number. Nth root of a was a positive number. Do you remember this? And n was an integer which was greater than 1. So can we write minus 7 power 1 by 3 as minus 1 into 7 power 1 by 3? Yes, we can write it like this. Now, can we write 7 power 1 by 3 as cube root of 7? Yes, we can write it as cube root of 7. So this is minus into cube root of 7. Minus into cube root of 7. So given form was which form? Given form was an exponential form. And this form is the radical form. Right? So this is the question number 1 of exercise 2.3. Now let us see question number 2. Tell whether the following statements are true or false. Again you have to check that whether the given statement is true or false by solving it. So the first part is question number 2. First part of question number 2 is 5 power 5 power 1 by 5 is equals to square root of 5. So is it true or false? What about this side? This side is fifth root of 5. Fifth root of 5. And on the right side, what is given? Square root of 5. So definitely they are not equal. It means the given statement is false. Now what? So the third part of question number 2 is square root of 49 is equals to square root of 7. So let us take the left hand side and solve it. Square root of 49. Can we write square root of 49 as 7 into 7? And the next step, can we write it like this? 7 square. Now, you should keep it in your mind. If there is no index written, it means this is a square root. This sign, square root of x or square root of x. We can write square root of x as in this form as well. Fine. So, here we can write it as square root of 7 square. Now if you remember the last property of the radicals, what was the last property? That is nth root of a power n could be written as a. These numbers would be cancelled with each other. So we have 7 at the right hand side. Now can somebody tell me the given statement is true or false? Yes, it is a false statement. Now let us proceed for the last question of this exercise. Okay, question number 3 of exercise 2.3 is, we are solving exercise 2.3. So question number 3 is, simplify the following radical expressions. So almost all the parts are on the similar pattern. Let us solve the fourth part of this question. Fourth part is cube root of minus 8 over 27. Now what about this minus sign? Can we write this minus sign with the numerator or with the denominator? We will write down this minus sign with the numerator, because as you remember, a fraction would be in the standard form when the negative number sign is in the numerator. We cannot have negative sign in the denominator for a fraction to be in the standard form. So here we will write down it as minus 8 over 27, cube root of minus 8 over 27. Now what would be our next step? We will factorize the numerator and the denominator. That is, if we factorize 8, we will have what? 2 into 2 into 2. And if we factorize 27, what would we have? 3 into 9, 27, 3 into 3 and 3 into 1. As all of you know how to prime factorize a number. So can we write it like this? Minus 2 into minus 2 into minus 2. Why I have written minus 3 times over here? Here we have taken minus into minus will give you plus, and then plus into minus will give you minus. So at the end we will have a negative sign. That's why we have written it like this. Now can we write it like this? Minus 2 power 3 and then 3 power 3. As the bases are same, we can add the powers. So it is cube root of 3. Now whichever property we will use, we have to mention it with the step in which we are using this property, parallel to the step. So which property we will use here? We will use here the second property of the radicals, that is nth root of a over b could be written as nth root of a divided by nth root of b. Do you remember this property? So whenever you are going to use some property, you will mention this property parallel to the step in which you are using it. So minus 2 power 3 cube root of minus 2 power 3 divided by cube root of 3 power 3. Now which property we will use at the next? Do you remember this property? Nth root of a power n. This was the last property of the radicals. This could be written as a. So if we have a same index of the radical and same power, we can write it like this, minus 2 divided by 3. So this is our required answer. I hope this concept is very clear to you. Now what you have to do is, you will practice exercise 2.3 and the relevant examples of this exercise as well. So students, good luck and Allah Hafiz.